Hi everybody, my name is Igor Drobyshev and I'm gonna do a quick summary of the project PREREAL. PREREAL stands for Improving Predictability of Circumboreal Forest Fire Activity. And in this project we tried to use the wealth of paleochronological and dendrochronological data together with modern observations to understand the drivers and possibilities to predict forest fire activity in boreal regions across the Northern Hemisphere. The project contained a lot of separate studies, and today I'm going to just show you a few of them which sort of exemplify diversity of approaches we have been using. And we will end up with some main points, main results. So the approach we took was to look very closely at a variety of proxy records. These included lake sediments, which give us long Holocene-wide perspective on the fire activity. We looked at the fire scars. Fire scars are annually resolved proxies, which are shorter. Typically, it's a few hundred years, the extent of these chronologies, but they give us much better resolved data, and that could be useful for all kind of bioclimatic modeling. And plus, we used the data from satellites and from the modern products, which provide comprehensive coverage of the modern fire activity in the boreal zone. So this is one of the studies we conducted. We looked at the dynamic of fire cycles in the eastern North America. In this particular case, it's largely area of Quebec. Fire cycle is the amount of years it takes for the area to burn completely, and it gives us an idea about the spatial characteristic of fire activity, special properties of fire activity. In this case, we used data from a number of landscapes which have been studied, and we used data on age structure of these landscapes, which gives us an idea about current and historical fire cycles. So, as you can see on the graph on the right, there's a strong pattern, very consistent pattern you see across most of the sites, which is the increase in the fire cycle, which means that fires become less common or fire activity simply declines. And this is typically related to the onset of post-Little Ice era, the period where climate has been probably less fire prone. So we try to understand if there's a connectivity, if there's a connection between the onset of this shift and the position of this landscape in a larger geographical context. And here we simply mapped the onset, and in color we have the date of this onset on this two-dimensional map, which is simply longitude to longitude. And what we see is that there's a much earlier onset, which is happening in the eastern side of the studied area. And this is the area which is more continental. Onsets do happen across the whole area, but they're way later. They occur much later in the eastern part, which is much more affected by Atlantic climate, much less of the continental type in terms of the climate type. We tested this effect using relatively recent data on a decade between 1910th and 1920th, the period where this part of the boreal zone has been experiencing very strong fire episodes. So we looked at the amount of forest, in this case percentage of the forest, which originated from the fires which occurred in this period. What we saw is that there's basically the same pattern. A large amount of forest has been burning in the western side of the area and much less in the east. So we made the conclusion that the continentality of the climate probably plays an important role in the way fire regimes respond to the climate forcing. To be more specific, we believe that continental climates are much more prone to climate-driven changes in fire regimes because they operate under the conditions when the landscapes are already relatively close to the thresholds, which would be indicative of good fire weather conditions when the fire can easily propagate across the landscape. Here is another study which I'd like to show you. This is a study in Sweden when we look at the modern fire activity about 20 years, 25 years to be exact. And we collect the data on human presence, amount of infrastructure, climate, vegetation type, to understand what are the main controls of two things: fire occurrence, number of fires, and the fire size. And in this case, I show the data on the fire size distribution. We see that fire size is negatively correlated with the road density, with human population density, which is not surprising. Large fires typically occur in the places where we have a few humans, where forests are relatively, I wouldn't say untouched, but they are not so often visited, though they have higher continuity in terms of the fuel continuity. And we also show that certain features of climate has a very strong positive correlation with fire size, like initial spread index, which is a part of fire weather index, the Canadian Fire Weather Index. We also demonstrate that there's two quite contrasting patterns which we observe between fire occurrence and fire size. Factors which tend to favor fire occurrence, they tend to disfavor fire size. So a lot of fires that occur in the places which are populated, heavily developed. Less fires occur in places which are relatively free from humans, but these are the large fires which occur there, so they are the ones which actually matter from ecological and economical perspectives. This is another study which we looked at Sweden. We tried to understand how does extreme fire episodes or extreme fires, what is the likelihood of these events under the current and under the future climates. In this case, we used year 2018 when a lot of fires occurred in Sweden. At certain days, there were more than 50 fires which were simultaneously active in the country. A situation quite unique. More than 20,000 hectares have been burned, which is again quite exceptional for this country. So the country has been divided into three parts: northern, middle, and southern Sweden. And for each part of the country, we looked at the probability of this event under the current climate, trend in probabilities of these events under the current climate, and the probability for this event under the future climate, under the conditions of increased temperature and eventually decreased precipitation. So what we see is that actually under the current climate, and this is data in the A section of this graph, and the data is based on analysis based on reanalysis data, we see that in general there's a trend towards less probable events of this type. So these larger episodes become less probable over the period covered by reanalysis data. At the same time, if we look at the projections, we see that there's an overall tendency towards these events become more common under the future climate. I also would like to draw attention to the fact that we have quite a variability in these projections, and some projections actually show decline in the probability, but overall pattern is the increase. Here is a study when we again look back at the historical data, in this case 2 data sets. One is a dendrochronological data set based on the fire scars. Here it's indicated by the crosses. And another one is paleo chronological data set based on sediments from the lakes, 2 lakes. And these lakes, they provided us with a chronologies where we reconstructed fire events based on fluxes of charcoal into the sediments. And apart from the dates of these fluxes, we also identified the error interval between error envelope, confidence envelope for each of the peaks in charcoal accumulation. And we tried to connect this to the dates which we reconstructed from the fire scars collected around these lakes. So as you can see, there's quite a lot of synchronicity in both data sets. But at the same time, there are years which are reconstructed from the dendro record, but they do not really have any correspondence in the paleochronological record. So in general, it's a good match, but we'll have to admit it's a partial match, and we're currently now on the analysis which eventually give us a clue how to partition signal from very local events happening, fires which happen just around these lakes, and events which are of more regional character. And eventually this will lead to better calibration of these two data streams. There's another study which has been done with paleo methods, which looked at the long-term history, Holocene-wide history of fire in Ural Mountains. It's eastern fringe of European boreal zone. And here we have reconstructed mean fire return interval, which has been declining, meaning that fire activity increased since the start of the Holocene. We observed a lot of dynamics in this mean fire interval. And we also tried to connect it to the other proxies of other paleochronological proxies of fire activity, which has been obtained in other parts of the boreal zone in Eurasia. And clearly there's certain synchrony in these proxies, which we believe are caused by climate variability. But overall, we need clearly more data to provide a more coherent picture and more sites to be analyzed before we come up to a confident conclusion on that. As I already mentioned, we have a number of sites which are currently in the progress being dated and analyzed. The overall scope of the project appeared to be way more ambitious than the time and monetary constraints allowed us to achieve. But we still continue with this work, and here I just want to show you the map of dendrochronological sites when we reconstruct fire activity. Most of the sites cover at least 500 years. Some of them are published. One which is published is presented on the right. This is a site from Russian Karelia on the border with Finland, where we reconstructed fire history on multiple plots in this area and developed reconstruction of fire cycle. We found pattern in this fire cycle, which we discuss, and we talk about climate and human forcing upon this dynamic. Clearly, a combination of multiple proxies or just information about human presence, land use patterns, they're all very handy in this type of discussions. And this type of multi-proxy analysis we are trying to do in all of the sites which we see on the map here. So as a probably one of the critical and final results of the project was development of empirical prediction system to reconstruct fire activity based on the data on climate prior to the start of the fire season. So in this case, we tried to model or predict behavior of monthly drought code, which is a measure of drought, and again a part of the Canadian fire weather system, using the data from on climate prior to the start of the season. We used two modes to predict, two ways to predict the the monthly drought code. The first mode used the data in the beginning of the calendar year to predict for the whole fire season, so from May till October. And for the mode 2, we predicted, for example, data for July using data from May, April, and March, and prediction was obtained then for June. So it was kind of moving frame with 1 month lead time. So in both cases, what we see is quite strong prediction skill, which is indicated by color here. It is slightly decays when it comes to the end of the fire season in the mode 1, because the time between data, between the period when which we used for prediction and the actual month for which prediction has been done was the largest. But it's somewhat better in the mode 2 when we had this moving sliding frame, which again gives us a clear message that there's a strong potential to develop this system or sort of invest into the system to make it more operational and available for forestry professionals and people involved in the protection of societies against the forest fires. This system is currently online. It may not be available right at the time when you will be looking at this presentation because there are some technical issues to solve, but I believe this is something which we will solve in the days to come, and this will be something to look at. So some concluding words. As a result of this project, we uncovered a number of very interesting and fascinating spatial and temporal patterns in boreal fire activity, which were observed across scales, both temporal and spatial scales. Our results indicate that there's a very strong potential to look at and develop the systems which give us a possibility to predict fire activity, to really develop an operational decision support for people who are intricately connected to these risks or related or have as a mandate the responsibility to handle these risks. There are clearly certain regions of the boreal zone where the prediction skill is somewhat low, and research would be needed to really identify the sources of this lack of skill and eventually alleviate these problems. Another interesting and much needed part of the research, which is still to come, is to connect projections which are climate driven with the projections of developments which are not directly climate driven, such as changes in forest cover, changes in the human land use patterns, or just the presence of humans in different landscapes, because this seems to be also an important driver of fire activity, even if climate remains the dominant one. Yeah, and I think with this, I thank you for your attention, and all the luck with your own research.